In this video we have a couple of exponential equations with the base e that we need to solve for. Now there's a few different ways that you could solve this, and the one that I'm going to use is the inverse of the exponential function. So as you can see here, we have y equals b to the x power. That's the standard form of an exponential function. And the inverse could be written as just switching the x and the y's. They switch spots. So instead of having y equals b to the x power, we have x equals b to the y power. So that's going to be the inverse of an exponential function. Well, if you ever wanted to write that in terms of y, which means just setting it equal to y, you'd have to bring in the log scale, and you would write it like this. Y equals log base b to the x power. So a lot of times we're switching back and forth from this equation, I should say this form to this form. So now if we look at part A right here, we have a variable in the exponent, and that's what messes us up. And we're going to have to isolate this part right here, which has the base e and the exponent. Isolate that, get it by itself, because then we could take the inverse form of an exponential function and rewrite it with our log form, and that gets rid of the exponent. It brings that y down to the regular level, I guess you'd say, and we could solve for it. So enough talk, let's go ahead and do this. I'm going to take away the 10, subtract 10 from both sides, so that goes away, and then I'm left with base e to the x minus 4 power, which equals 33. Now I'm going to switch forms, so I go from exponential form right here to log form. And how I like to do this is I take my base and I rewrite it as my little base of the log. So I need to write log here first, and then I take my big base and I write it as my little base. And then the exponent was written as y up here. Well, now that goes on the outside of the equal sign, or I should say on the other side of the equal sign of the log. So we want to hold off on that, and I guess we would say, what is written with the log? Well, that's the part that was on the other side of the equal sign of exponential form. So that was the 33, and I'm going to rewrite that in parentheses. So then the other side of the equal sign, we need to write our exponent, which was x minus 4. Now that could get really confusing for some people, especially when you're trying to learn it for the first time. So what I like to do is just kind of think less about it in a way. I take my base, which is my big number here, and I rewrite it as my little base right there, and then I just switch spots with my x and y, and that ends up giving me what we need to work with. Okay, now at this point you could go about it two different ways. You could use your calculator and evaluate log base b of 33. That's going to give me about 3.4965. So that's going to be an approximation, and then we have x minus 4. And I could go ahead and keep solving that, which is going to be adding 4 to both sides. So x is going to be approximately 7.4965 as my final answer. So I want to go back here now. Log base e of 33. I said that I could go about that two different ways. And one way is just evaluate it in the calculator as is. But if you don't have a base e in the calculator, you could also use the natural log. And that's written as ln of x. That equals y. And that's going to be the same thing as if you had log base b of x. So in my equation, we had log base e of 33. You could write that as the natural log of 33. And that's going to give us 3.4965 as well. So either way would work. Okay, on to part B, and we're going to go about solving part B the same way we did part A, which means we have to get that base e and the exponent by itself first. So the first move we're going to do is add 4. That cancels that out. We have to add 4 to the right side as well to make everything balanced. So I'm going to have a negative 9 times e to the 9x power, which equals negative 28. To undo the multiplication of negative 9, I'm going to divide negative 9. Negative 9 over negative 9 is just 1, so that goes away, and I divide the right side by negative 9 as well. So now we're left with e to the 9x power, and that's going to be approximately 3.1111. So we're going to round that to 4 decimal spots. Now we have that isolated just the way we want it. And I'm going to use our two different forms here, which is the inverses of an exponential function, which means I'm going to take my base e right here, and I'm going to write it with a log, but instead of being a big base, we're going to make it our little base. And then I just take these two parts right here and switch spots. So in parentheses, we're going to have a 3.1111, which is approximately 9x, and I could solve from there. So we could evaluate log base e 3.111 in our calculator, or we could apply natural log. Remember that log base e of x equals y, and that's the same thing as natural log of x. That would also equal y. So now I have 1.1350, which is approximately 9x. I'm going to divide both sides by 9, and that's going to give me my final answer. That's going to be approximately 0.1261 for x. And there we go.